Hello everyone, thank you for watching my presentation. I will introduce my paper, whose title is Availability Evaluation and Maintenance Policy of Data Center Infrastructure. My name is Kádna, my colleagues are Araujo and Fernanda. This is my email. You are from the Federal University of Pernambuco and Federal University of Agrários of Pernambuco, Brazil. This is the outline. First, I will talk about the introduction, background, methodology. After that, I will talk about our models, and next, I will conclude the paper. After the popularization of cloud compute, the demand for everything as a service increased considerably. So we need more and more high availability levels. But behind that, there is a need to build new data center infrastructure. The main concern is based on the choice for maintenance policy in order to achieve high availability and reliability levels. Then our objective is to evaluate the availability of Tier 1 data center and to simulate a maintenance policy encompassed at different service levels, or SLA. To compute the dependability requirements for data center, there are many metrics can be used. For instance, in this paper, use the MTTF, or mean time to failure, is related the time to exposure to failure, and MTTR is the mean time to repair, is related to MTTF and the downtime and availability, and the availability is related to the time to failure and repair, and the maintainability is the availability of the system to undergo modifications and repair over time. Our methodology is based on some steps like system understanding, metrics identification, construction of dependability models, models evaluation, scenario creation, and synthesize the data. Data center normally use the three-layer models like this figure. For instance, in core layer you have the routers, in aggregation layer you have layer 3 switches, and in access we have the chassis. To build the models of this work, we use the two techniques like a reliability block diagram and stochastic pattern. We use the Mercury tool in version 4.8. The tool is free and can be downloaded in this website. For this work, we built 5 models. In this column, you can see the models. Here, you can see the components, and here the time to repair. In this table you can see the components, the MTTF, and the reduction and source of these components. Now you can see the models for the blade system. Here you have the models to represent the data center, Tier 1. For instance, we have 3 networks. For this one, we don't have multi-component redundancy. For the second, we have 5 chassis. In the third model, you have 4 switches and 20 blade chassis. Here you have the SPN model that has the maintenance policy. In this model, you represent the failure of DC for net long distribution and in this case the DC can be up or down, and we have one team to repair the components of the system. The second network represents the operation of the system. The system can be up or down. Now you have the result analysis after evaluation of a period of a year. For instance, you have the models. We can see the availability results. Note that all models can achieve at least 3 nights in the availability. Here we have the reliability of the system and the MTTF achieved after the evaluation. Here you can see the experimental study for the evaluation of FSPN model. We have 9 classes of SLAs. We have 3 times for interval of the maintenance and 3 times to repair. And now you can see the results of availability. In this case, no one network couldn't achieve the availability suggested for tier 1. We have a hierarchical approach. When we evaluated the first model, we used the result in the second. In the second, we used the result in the next two models. It's very difficult to achieve high availability when the system's MTTF are relatively low, and when preventive maintenance is dependent on long intervals. Long time to repair also influencing the availability, and due to the lack of redundancy of this network, it doesn't not even show 3 nines in the availability. Thank you so much.